You thought through the visual tools that might be most effective, and now it's time to actually turn this into a plot. There are many tools. Depending on the programming language that you're using, there might be a large number of libraries internally and externally that support plotting. Some programming language don't have anything. So if you're using one of those, you might just write your results to disk and then programmatically, ideally, create your plot by reading in the data that have been produced through, say, a simulation run or something. I want to re-emphasize that you should not get limited by the tools and their defaults. You have to invest time to research which tool helps you realize the vision for your data visualization. And then two, how can you still manipulate the default settings in a way that conveys the story of your data and not the design choices by somebody who set up this library. If necessary, you may have to program your own graphics. That means that you may use the default plotting from something like matplotlib, and then you use those figures that are being created and you change all the elements in those figures. And we'll talk a little bit about that. Here's a range of plotting tools. There are some for Python, Seaborn, Matplotlib is something that we have used plenty already. Plotly is used often in web environments for kind of dynamic plotting. GMT is the basis for map making that we will actually use later on through the PyGMT API that has been developed for Python. NuPlot and NuPlot scripts are command line plotting tools in the Linux Unix environment, and then of course everything else that the Python environment provides for you. But don't also be limited by Python. Maybe there are exceptionally useful libraries in something like R or Julia or other programming languages that you can leverage if you write your results into a file, read that file with that different language, and then just use that to display your data. So be creative and not limited by some preset choice of tools. Talking a little bit about Matplotlib, there's a PyPlot API. API is Application Programming Interface, so it's a set of functions that are being provided for you. Matplotlib.pyplot is intended for simple cases of programmatic plot generation. It opens figures on your screen and consists of a simple figure GUI manager. So if you say pyplot plot, you get a figure that has a frame, that has axes, tick marks, and it may or may not have a grid. This is a very basic figure, but you can take that figure object and mess around with it and changes. And that's where the object-oriented API comes in. Matplotlib creates figure objects, and that's where we leave it with the object orientation here. You can take that and change all of the elements in that. If you need more control and customization, work directly with the figure objects that Matplotlib generates for you. What does this look like? Here is a bit of an overview of some of the pyplot functions. This example shows what we have done before. We import NumPy, and then we import matplotlib.pyplot as PLT. That's a common way how we import this. We don't have to call it PLT, but it's a nice shortcut, and it still tells you where the functions come from that you're using. This example here uses NumPy to create a list of numbers from 0 to 5 in 0.1 intervals. And then we're using NumPy to calculate the sign of x and stuff that into a variable y. And then we're plotting y over x. And if we were now to say PLT show, then we'd see a nice sine curve. Another list of functions other than plot that pyplot provides is shown here. We don't have to go over the details, but there's a bar plot. We can make some kind of histogram. You can make a box plot and other things. These three dots indicate that there's a long list of functions. And if there's something that you want to do, it's quite likely that at least the prototype of that plot already exists in this list. And then again, you can take the figure object that is being created here and manipulate it to your liking. To do this, you need to know the matplotlib figure anatomy. You can see here a standard figure. You can see that that all of this is labeled. So I've referred to some of these names already, right? There are tick marks along here, but there are major tick marks that are a little longer and minor tick marks between the major tick mark labels. You can also add minor tick mark labels. And then on the y-axis here, there's a y-axis label. On the x-axis, the same thing. There's the x-axis label, and here you can see that there are minor tick labels added in between the major tick labels. The figure edges or the frame edges here, they are called spines. You can manipulate those too. You can decide whether or not you want to have your x-axis labels on the left-hand side or on the right-hand side. In the background here, you can see a grid, which you can turn on and off and manipulate. Inside of the figure, you see these dots. Those are markers in a scatter plot. Here we have a line that could also have markers at discrete points. The entire thing is what we call axes. This is what's happening inside of here. And everything, including the labels and the figures and the title, etc., is called the figure. The figure may contain a legend. This I mentioned before, a little box with lines and then some label here. There might be a title. These elements you can all alter. You can change the length, the thickness, the color, whatever you want. You just need to find the path to these individual objects so that you can mess around with them. And the matplotlib documentation helps with that. Lastly, a higher level plotting package than PyPlot is Seaborn, which focuses on statistical data visualization. From their documentation, you can see that Seaborn is a library for making statistical graphics in Python. It builds on top of matplotlib and integrates closely with pandas data structures. So if your data are already in pandas, Seaborn is a natural way to visualize things. And you can see here that, this is a list of example plots that, perhaps clustering is pretty straightforward and easy to do, and showing densities of cluster distributions, showing means and variances around your data, various kinds of scatter plots, small multiples. Important here is that this is built on matplotlib. So theoretically, you could do all of this yourself by using plot and then manipulating your figure and calculating all of these things. But for a lot of cases, you may not want to redo that and simply reuse the capabilities that Seaborn already provides for you. And this is what I mean by choosing the right tool for the plot that you want to make. Maybe somebody already did it, it's quite likely, or somebody made something that is quite close to what it is that you want to do. It is time well invested to explore around a little bit, do your research, and try to find a tool that is as close as possible to what it is that you want, and then continue from there.